In the previous videos, we have seen 3 different examples or harmful bias connected to AI and machine learning. In the first 2 cases, the bias was transferred to the AI system, where data that suffered from human biases. In the first case, the transfer was straightforward. Even so, it was not easy to detect, partly because it was hidden in the algorithms, and partly because there was a strong belief that there was no bias. In the second case, it was even more difficult because there was a combined effect of data that was skewed due to prejudice on a societal level and an overly simplified use of the model. In the third example, we looked at the combination of 2 intended biases, favoring Google's revenue over other possible values, and favoring links that fit the user's historical choices. This combination in turn lead to other non-intended biases in the form of what is sometimes called information bubbles. What these 3 examples have in common is that they tend to conserve, reaffirm, and amplify human prejudices, and also to hide them behind seemingly unbiased appearance that is very hard for the untrained user and also for the expert to see through. How can we handle these problems? In the task for this lesson, we want you to discuss this question in the course forum. We will start the discussion for you in this video, and then you continue the discussion by providing your own thoughts. In the course forum, you will also find some more information and ideas in the recent section. Let's start with the third example. In this example, the main value that the system was biased to favor was Google's revenue. Is it possible to make Google design their algorithms? They do not only favor their revenue but also, for instance, scientific accuracy and critical thinking among its users. Alternatively, is it possible to find a better proxy than the user's search history for what is actually in the user's interest? Or that require an even greater invasion of privacy? One thing we need to acknowledge is that what I call intended bias before is in fact an inherent feature in all systems that make decisions, including humans, other animals, and machines. Namely that the algorithm favors and promotes a particular value or set of values. All decisions do that. In fact, to make a decision is per definition to favor some value over others. That is, no decision system, including AI systems, are or can be value-free. There's nothing strange about that, and there's nothing we can do about it, even if we wanted to. Making decisions is per definition to favor some values over others. As constructors or users of AI systems, we want the system to promote certain values and not others. That is the whole purpose of building and using these systems. What we can do and need to do is to be aware that this is the case and to be aware of which values are promoted and which are not by the AI systems. Being aware of which values are promoted and which not by an AI system is very important for the users of the system. Is also very important for everyone who develops AI systems. For those who develop AI systems, it is also very important to understand how values are built into or transferred to an AI system consciously or unconsciously, and of course to think very carefully through which values we want to be included in the system. This way of thinking can also be applied to the other example. Indicates a recruitment. The seemingly obvious value we want to promote is to hire the person best suited for the job. But in our example, the choice of training data did not align sufficiently with this aim. The training data came from a large selection of recruitments, without giving any particular thought to whether they had been successful in the sense of actually hiring the best person for the job. But to come to terms with this, it's not necessarily as easy as it may sound. We can follow up on each of the recruitment cases for which we gather our data to see if the person who was eventually hired was good enough not to be fact because of incompetence. Though, even that may take quite a lot of effort to find out. Also that the person who was hired was not fired on grounds of incompetence does not guarantee that the very best person was hired or that there was no discrimination involved. Assuming that in most cases is more than one applicant who is good enough, there is still room for prejudice. From a strict recruitment perspective, hiring someone who is good enough is often just that, good enough for the purpose or the recruitment. But if we also want to avoid discrimination, we may want to actively add a bias against discrimination in the system. We could do that by biasing the training data. For instance, by not using training data from recruitment processes that have been obviously discriminating. Another option that is available if we do not want ethnicity or gender to play a role in recruitment would be to weed out these parameters from the training data. Weeding out the unwanted information from the input data when the system is in actual use will typically have lower chance of success. If the AI has already made up its mind based on the training data, the gender and ethnicity is relevant, it will probably be able to use other parameters in the input data to find out the gender and the ethnicity of the applicants. The complicating factor here is that in some cases, one wants to take affirmative action. In this case is, of course, information about ethnicity, gender, or disabilities may have to be included. In those cases, it will therefore not be enough to bias the training data. Instead, we might have to think about how to bias the algorithms in a desirable direction in order to facilitate thinking about bias when developing AI systems and increase the probability that someone in the group notice if there is a bias in the data or the instructions. It is probably also a good idea to actively work for a more inclusive group of coworkers. Second of our examples is even more difficult to deal with since the bias in the data did not come from the prejudice of individual recruiters, but from the society as a whole. That does not, on the other hand, mean that AI cannot be used in a creative way to mitigate this problem. It is still possible to weed out information from the data that we do not want to guide the decisions of the system. A more difficult and expensive but maybe more effective measure would, of course, be to build a more advanced AI that can see beyond simple correlation and put this data into a wider perspective. I will now leave it to you to discuss how to handle bias in AI systems in the course discussion forum. Thank you for listening and good luck with the next lesson.